In this video, I will be reacting to a video from a channel called Brightside, titled The Entire History of the Universe in 8 Minutes. So, without further ado, let's get going.
And with a big bang, and for some time, there was nothing but very hot matter flying in all directions at the speed of light. Very shortly, though, the first star appeared. Its name was Methuselah, and for a long time it confused astronomers who believed it might be older than the universe itself.
Okay, so I don't really understand the logic behind that, because the whole idea behind the Big Bang is that the universe is where everything is, so before the Big Bang there was nothing, so how could there be a star like Methuselah before the Big Bang? Because if there was nothing before the Big Bang, Methuselah is something. So I mean, I think it's pretty obvious that Methuselah came after the Big Bang.
Soon after, on a cosmic scale of course, the first black hole started forming. Scientists believe they're what's left of exploded stars, but that's not for sure even today.
Well, and there's also another theory that if you somehow fell into a black hole and made it out the other end, you would come out of a white hole, because a black hole pulls everything into it, and a white hole it isn't really a hole at all, actually, because it expels everything outward. And the reason we haven't tested that is because any black hole that we could ever even dream of getting to any time in the foreseeable future, those black holes are really small, so you go through a process called spaghettification, and you basically die right at the event horizon or shortly after. But supermassive black holes, like the ones at the centers of galaxies, such as Sagittarius A, I believe it's called, in the center of the Milky Way, if you went through that at the perfect angle, you might be able to come out the other side without being spaghettified, but you'd have to have a rocket and a spacesuit that can last that long, so that's why we can't really test this.
At the same time, cosmic dust and matter began ionizing, helping to form new stars. In the end, it led to thousands and then millions of stars appearing in space. The universe, left cold after the initial enormous explosion, started heating up again. In about 100 million years, stars began forming clusters, which we know as galaxies. The earliest of them didn't include any planets, though. It was still too soon for matter to shape into something so big and solid. So, galaxies mainly consisted of stars and interstellar gas. The oldest ones are believed to have been born in a relatively small patch of sky called Hubble Ultra-Deep Field, named so after the Hubble Space Telescope. It includes over 10,000 galaxies. After some time, the first known exoplanet was born. It was also dubbed Methuselah for its incredibly old age.
Well, and just to clarify, an exoplanet and a planet is really the same thing. It's really just about distance, that if it's in the same solar system as the Earth, we call it a planet, and if it's not, we call it an exoplanet. And that's regardless of the distance. Like, if it's like the closest possible thing to our solar system, it's still an exoplanet, but if it's in a completely different galaxy, it's still an exoplanet. And an interesting thing about exoplanets is, in the nearest universe to ours is the Proxima Centauri system, and the second planet from that sun, which is very creatively, I'm being sarcastic, very creatively named Proxima Centauri b, we actually think that it might be habitable because it's within the habitable zone, and we have reason to believe that it has water.
moving in the orbit of two stars at once, located 12,500 light years away from Earth, which then didn't even exist. And of course, I wasn't around either. Finally began taking shape. Our home galaxy is a barred spiral, which means it has a bar at the center and several arms. And on top of one of those, our solar system would eventually be born. Right now, it's no more than a roughly circular blob, though. The Milky Way started forming only about 200 million years after the Big Bang, like many other galaxies. But only now, it's becoming closer to what we know and love. At the same time, millions of other galaxies burst into existence with stars and planets clustering together. About 11.5 billion years ago, a peculiar planet popped up. Captain B is the oldest known exoplanet, uncannily similar to Earth in everything. Nobody knows if it's inhabited, but it sure can be. It had more than enough time to develop life. Although spiral is the most common type of galaxy out.
Well, the development of life and maybe civilization, unless that's taking it a little too far, it's not just about time, it also has to be the right location. Like if it's a rogue planet and not attached to any star, it's less likely to have life, but it still could technically, because if there's ice on the planet, there might be life underneath it if it's something like a water world, but just not really Earth-like life.
Out there, we know the name of probably the oldest one. It's BX 442, whose light reaches us across 10.7 billion years. At about the same time, the rate at which stars were appearing across the universe reached its peak. Every second, thousands upon thousands of new stars would burst into existence, immediately starting to gravitate toward each other, forming clusters, and then later becoming galaxies. At this point, the temperature of the universe slowly began to fall. Until now, it was hotter than the sun's surface and quite dense, like me. But starting 11 billion years ago...
Wait. Did he say dense like me? Sorry, that's off subject.
It all changed. Powerful galactic cores and newborn stars stopped sending out so much energy into space, and the first metal-rich stars began appearing. Metals made them cool down at a higher rate, so the universe stepped on its track to becoming habitable. With less than 10 billion years before humans appeared, the first group of galaxies emerged. JKCS 041 is the farthest known galactic cluster, born just 200 million years before the universe reached a third of its current size, a mere moment on a cosmic scale. And at roughly the same time, Bernard's star appears in the Milky Way. It's one of the most ancient stars in our galaxy, and also our close neighbor, being just 6 light years away from the Sun. As the universe continues to expand, the Milky Way goes on growing and taking the familiar shape, until about 8.8.
Yeah, and because galaxies grow, they can sometimes end up colliding, or just outright absorbing other galaxies. We actually know, or at least have a pretty good idea, that our galaxy, the Milky Way, will, in the very distant future, collide with a nearby galaxy called the Andromeda Galaxy, and nothing really major would happen. Like, if humans are still around then, and the Earth is still the same, which I don't think it will be, but there's no explosions or anything, is my point. The galaxies just kind of gracefully merge into one larger spiral, but sometimes they don't join as much as some galaxies just kind of stop existing as they get swallowed. The largest galaxy that we know of is called IC1101. It's kind of a bizarre name, I think, but it's actually growing because, like, as it expands, it goes into the space of nearby smaller galaxies, and it collides with them and absorbs them and just becomes bigger.
8 billion years ago, it had only its thick disk, a structure around the center where older gas-rich stars mostly dwell. Now, the thin disk starts forming. It's a thinner layer within the thick disk, in which younger stars, more abundant in metals, appear. Stars still get born at an astonishing rate in our galaxy, as well as in many others across the ever-growing universe. That is, until about 8 billion years ago, when this growth rate finally began to subside. This occurred with lots of other galaxies too, of course, mostly because there was not enough matter to form new stars in such a cluttered space. Then, roughly 7.5 billion years ago, something happened a long way from our galaxy, and a gamma ray burst began traveling across the universe, reaching Earth only in 2008. Such bursts usually occur because of a star exploding into a supernova, and they're really spectacular to behold. But this one was special. It was the furthest and brightest one ever observed in history. If it were as close to us as the Sun, it would be 21 quadrillion times brighter than our star.
Yeah, because what a supernova is just when a star, like our Sun is a star, that they just reach the end of their lifespan and they shrink and then they explode outwards, so all of that energy and light just comes out. I didn't actually know about this thing he's talking about from 2008. I wouldn't have seen it because I'm not that old, in case you thought I was. But anyway, let's continue.
That's 15 zeros, just so you know. Although events such as this happened in the far corners of the universe, it continued to cool down at an ever-increasing pace. About 7.2 billion years ago, the average temperature of space was only 5 degrees Kelvin, or minus 450 degrees Fahrenheit. Still...
And the Kelvin scale is where 0 is the lowest temperature possible in the universe. So basically 5 degrees Kelvin is like really cold, like colder than almost anything we know of.
It was only a few degrees warmer than it is today at minus 454 degrees. In the end, the universe will eventually reach the absolute zero, the temperature at which atoms don't move at all. Dark and absolutely still. Anyway, it's still way long before this event, and we're now at 6.5 billion years ago, the time when the Milky Way started taking its recognizable spiral shape at long last. Now, it won't be long until our solar system forms, but there are still things to come before that. Many of the older galaxies have already taken their current shapes, and stars kept forming and exploding, leaving behind quasars.
Well, not all stars explode when they die. There's, depending on the size of the star or just the nature of it in general. As I mentioned before, some will undergo a supernova where they just explode violently, like a big show. But others will just end up turning into a white dwarf, I believe, which is just it's pretty self-explanatory. It's white and it's small, so it's a white dwarf.
Quasars and black holes, which in their turn gave birth to other galaxies. 6 billion years ago, and dark energy, the most mysterious force in the universe to this day, somehow accelerates the speed at which the universe expands. No one is still sure how it does it, but the facts are these for the moment. Gravity isn't the only force that keeps objects apart in space.
Well, and he touches on in this video that the universe is expanding, and our idea, or the most widely accepted idea about the universe, is that it'll end in, or for people who think it will end, that it'll end in the Big Crunch, which is when at some point the universe stops expanding, it starts shrinking, and it's basically just a reversal of the expanding half, that it just shrinks until it becomes so small that it reaches the Planck limit, and the Planck limit is the smallest something can get, and after that it just doesn't exist because it's too small to exist.
Still, nobody knows much about this strange energy, so nothing is certain. 5.5 billion years ago, the solar nebula began collapsing. It's important for us because this nebula is what would eventually become the solar system. Right now, it's no more than a ginormous cloud of interstellar gas and dust, and it would take another billion years for it to clump together and form our star and the planets orbiting it. In the meantime, the Milky Way has finally become a complete barred spiral as we know it today. New stars forming, supernovae exploding, all of this had never stopped happening in space. And yet there was one event, roughly 4.6 billion years ago, that mattered the most to us: the formation of the sun. The cloud of dust and gas I mentioned earlier had finally collapsed enough to form a star, and it took just another couple of million years for the Earth to be born. It was extremely hot back then, and there was no chance for any life to survive. But after a few 100 million years, the miracle happened, and the first living creatures appeared on the planet's surface.
It might not exactly be a miracle, because we actually have reason to believe that at some point there was life on Mars and Venus. We don't exactly have evidence of that, but there could have been like oceans on either one, and I don't know, just ordinary life. So it's really just about being in the habitable zone and having a thick enough, large enough atmosphere. Mars is actually right at the edge of the habitable zone, meaning that it's just really cold because it's on the farther edge of the habitable zone. But its atmosphere is too thin to protect from things like radiation and other harmful things from the sun and outer space.
Since then, a lot of things, both good and bad, came to Earth. But in the end, here we are, on the most unique and undoubtedly beautiful planet in the whole known universe.
I mean, we don't know that it's the most unique in the whole universe because we have no idea what's going on in the vast majority of the universe.